Hello, welcome to this Corner Tech Pit video. Today we're talking about compilation errors, which can happen. Sometimes you're programming away and you go to do a download and you get a file compilation error. So I've captured a bunch of the common ones in a program, and we'll go through them. And by the end, you should know how to kind of identify them, locate them in the program, and rectify them there. So to start with, if we go on the processor in the project navigator and just right click it, look at logic user settings, some compilation errors can be configured to either be an error. In the case of an error, if you have one in your program, it won't let you download. You can't proceed. Or you can configure it to be a warning. In these cases, a warning is just that. So it'll come up as a warning. And if you say, no, I'm aware of that, I want to proceed, it'll let you. Or in the case where you just don't care about this specific type here, you can say allow and it will do neither, and just let the download proceed, and no issues there if you have something that you're not concerned with. So anyway, so let's assume we're about to do a download to our processor here. So we'll hit the download button and see how we can identify these compilation errors. So first it says fatal compilation error were found, and if we click OK, a tool will come up called the output window, which will help us kind of identify what the errors are. So here it says warning, the second register of a floating point was accessed. So, and it says it's at C8. So that's kind of a grid method. So if we went C and then down to 8, we could find that issue much quicker, because remember, you can have multiple subroutines and it could be hard to find. If you just double click it on the output window, it takes you right to the error, which is pretty handy. So in this case, we have register 1, and it's a real. So a real number uses 32 bits, as does like a double integer, obviously. Timers, counters also are instances where you'll use 2 registers. Lots of configuration items use multiple registers. So here we got R1 and R2 consumed since it's a real. And then it's saying if R1 is greater than R3, R3 would obviously use R3 and R4. Then it says, if that's true, move R3 to R2. So here's where I've purposely kind of created the problem. So R2 is the upper register of R1. So that would be a conflict, and certainly would screw the math up there. So we have to resolve that by just picking a appropriate register that's clear and not in conflict there. So now if we try a download there, that actual 1 is gone, but there's many more. So here it says we have a duplicate coil. So let's double click that and then go up to this duplicate coil. You can see we have register 101 on the first one, a bit 103, and again register 103 on the third one. So there are cases where I use multiple coils, where I might have multiple subroutines and I don't have them all turned on. So I might have the same registers in both. So I have done it. It's not a common thing. And in my case here, I have my multiple coils as an error. So if this was the only error or in the program, it would stop us from downloading. So since they're in parallel there, this one is most obviously a mistake. So we'll just go ahead and delete that, and we should be able to move on. Now, I've been trying to download so far. There's times obviously when you're programming and you don't have a processor hooked up yet, so you may not want to download, but since you're programming away and you want to make sure your program is error-free, you might want to check it here. So here's another way you can do the exact same thing. We'll just close this output window. And then if you do the verify, their fatal compilation errors come up again. And again, you've got a window, displaying them. In this case, it says invalid IO assignment main D4. So let's double click that. Okay, so here we have a bit of an element that we didn't address at all. So the processor has no way of calculating that. So it just needs to be addressed, and then we'll be able to go ahead and do a download. So you'd obviously pick the proper right address, but we're just in a demonstration program. So that one should be gone. So we'll try to verify again there. And still we have fatal compilation errors. It says rung inputs and outputs are not equal. So let's have a look at what we got going on there. Okay, so here we've got a rung. It's actually the same rung we just worked on, and it does not have an output. So obviously it can't be resolved by the processor. It's a fatal error, and so we need to get an output on that. And okay, so try another download here, and that one should disappear, and it did. So, or around function blocks. So this is a common thing that we like to use as an or around function block. So this says if R1 is greater than R3, move R3 to R5 and turn on the coil. Or if F4 is not pushed and 111 is high, turn on the coil. So that's an or around a function block. Very common. We do want, in this case, that logic to work. There's nothing wrong with it. And we can correct that or around function block issues back again in the user settings. So back in user settings, you see this function blocks, allow or around function blocks. It comes default not selected. So I put this in because it's quite a common one for people to run into. So we'll try another download here. That one's disappeared. Still fatal. So we have output elements must appear at the end of the rung. So let's have a look here, double clicking again. There's the output, and to the right of it, I've got an input. The rightmost element has to be the output. So this is a no-no. So we're going to delete that, and that should take care of that one. Okay, again, a download attempt. And it says that function blocks cannot appear in a branch, which is true. So if we go here, here is some logic. So this is saying that if R1 is greater than 75, turn on bit 108, that would turn this bottom branch on. And then this is the same R1 greater than 25. So what this would do is hold it on until it was not greater than 25. So let's say you have a pump and a tank situation, and you have the level at 75. And you want to run that pump till it's 25. Well, this logic is just fine for doing that, but we can't have the ors around function blocks in our case. So we're just going to select that and blow it away. And then it is quite easy to do the same thing exactly. And I've got the same logic here, which is if R1 is greater than 75, turn on that same bit. But down here, I have, instead of the rung in parallel, I have this second rung just turning on another bit. So this M110 is up here in parallel instead of the block being in parallel. So it's saying, again, if R1 is greater than 75, that will turn on. Obviously, this is the same R1, so it's also greater than 25. So this 110 will be on, and this 109, 110 will hold that rung in until that level's below 25. So that works just fine. It's just the way to use function blocks in a parallel fashion there. So we'll download again, getting closer to done here. Still fatal though. And so it says we have a syntax error here, so we're double clicking on that. This is quite a common one where we end up with an orphaned rung. You either just put the coil or the element too far from the left-hand margin, or you delete something upstream and you end up with just a unresolvable orphaned rung. So the way to solve this is just to kind of go directly to the left-hand side of it in the margin there, right-click it, and then just select new rung, and it'll join it up for you, and that'll resolve that issue there. So let's try another download. We're getting closer. So now this says non-fatal compilation errors were found. Do you want to continue? So if we said yes, it would continue and it would go through with the download. Because remember, a warning doesn't stop you from downloading. It's just something that makes you aware of an issue. But we're going to say no. Let's have a look. So this says the screen set is the first screen. So you have multiple graphic screens in the Horner controller. It says the one that you've got selected to pop up first is empty. So let's go there. And so here's our screen. I haven't done any graphics in this screen. So it is actually empty. So it's, again, just a warning. If you want to run your processor without graphics, you can do that, but it's not common. So we've elected to give you a warning saying, hey, did you mean to build some logic? So let's just grab a shape of some sort and put it there. So that's a graphic, not one that you might use, but it's a graphic that'll show something's on the screen. So let's try one more download here. And again, we have a warning again. So we could say yes, and it would download, but we want to have a look. So an object defined for the page is partially completely out of the bounds of the screen. So the screen, in our case here, I'm using a 4-inch. This only happens, this isn't as common, but it only happens when somebody started out with a large screen unit. Remember, Cscape software, the programs can move from processor to processor, so you can upgrade, downgrade, use your logic in multiple processors. So this is caused when somebody had a larger screen and they want to use the same logic on a smaller screen. So let's double click here and it'll take you to the screen. But remember, the problem is it's out of bounds. So this bit of logic or a bit of graphics that's causing a problem is actually out on the side here. So that's why we can't see it. So the way to resolve this, although it should have happened automatically for you, the way to resolve it is to go into the hardware configuration and you want to select that larger processor again. So we'll go from, we're using the Canvas 4, we're going to just go, let's go right up to the 10-inch and say okay. And this is where this should automatically solve this issue before it occurs, but we'll say no. And here's our out of bounds graphics way down here. So this is the size of our smaller processor here. So we'll just drag that back up there, and then we can switch back to that smaller processor, and it should work just fine there. So we're back at the 4-inch again, and okay. And again, it's trying to make sure our issues are solved, but we'll say no because we solved them manually there. And let's go download again here. And now we've got no warnings. This is the dialog box we've been looking for a while. So if we go ahead and hit OK, our download will start, and we're happy. So anyways, hopefully this helps you. First of all, identify if you have compilation errors. You should know now how to locate them in your program. And for all the instances I've showed you, rectify the problem. So thanks for watching the video.